Do you see the screen now?
Yes, doctor.
Okay. So we were doing the problem of the drilling operation. We solved for the machining time, and now we should determine the metal removal rate. In drilling operation, how we determine the removal rate? We have knowing the cross-sectional area of the drill and knowing the advancing velocity, the feed rate Fr, then we can multiply the cross-sectional area AC by the feed rate. The cross-sectional area is simply given by pi d square over 4. And Fr was already calculated now, okay? So all we have to do is to multiply the cross-sectional area by Fr, we get the material removal, okay? Any question on this problem? Another problem. A peripheral milling operation is performed on the top surface of a rectangular workport which is 300 millimeter long by 100 millimeter wide. The milling cutter, which is 75 millimeter in diameter and has 4 teeth, overhangs the width of the part on both sides. The cutting conditions are V equals to 80 meters per minute, F equals to 0.2 millimeter per tooth, and D equals to 7 millimeter. Determine the time to make one pass across the surface and the material removal rate during the cut. So first here, when they gave us the number of teeth, okay, this will, because when you have 4 teeth, then you can do, if you want, each one will do a certain job. So at the end, you should sum the job of all teeth, okay? So for instance, for example, if you want to calculate the feed rate, okay? In general, here, since we have 4 teeth, so we should do 4 times the feed rate of one tooth, okay? So here, for example, we have that per tooth, the feed is 0.2 millimeter, okay? So here we multiply F, we should multiply F per tooth by N, and then we multiply by the number of teeth, okay? So just the difference is here that we should account for the number of teeth in order to find the total feed rate, okay? And of course, to find the feed rate, we should know F is given. We should know the number of teeth also given. Still, we should find the find the value of N, which is rotational speed. To find the rotational speed, we have the rotational speed V. You have the linear and the angular, okay? N is the angular speed in revolution per minute. V is the linear speed, so you have a relation between V and N. It is the same in milling, drilling, and turning. The same relation apply. So you have to divide V by pi d. So here they gave us the linear velocity V. In general, it's called the cutting speed. We have also the diameter 75 millimeter. So we can calculate the value of N. Since just we pay attention here for units, we have V in meter while D in millimeter. So we convert to same unit. Here, for example, you can choose to convert V to millimeter per minute. Then you will get 80,000 millimeter over 75 pi in millimeters. So millimeter will simplify, we'll just have the unit of per minute, so revolution per minute. So we get the value of N, and then from N, we can now move to the calculation of the feed rate, which will be calculated here as the number of teeth we have, N, times for each tooth, we have that the if you want the corresponding rate will be equal to F, which is 0.2 millimeter per tooth times N. Okay, and in this way we can calculate the total feed rate. Now, They want us to determine the time needed to make one pass across the surface. So here always you should pay attention for the type of the operation, because in milling we have seen together that we have several types of milling. We have peripheral milling, we have face milling, and depending on this, what will change is the approach distance. So to remind you, if we go back to our equations here, we have seen several types of milling operation, and depending on the type of milling operations, the approach distance equation will vary. So this is the figure of peripheral milling. For peripheral milling, the corresponding equation to use is this one, which is that the approach distance is radical d times big D minus small d, where you can see in the figure that small d represents the depth of the cutter in the work part. This is the depth you will remove, and d represents the diameter of the cutter. So this is the equation we will use in this problem. Radical d times d minus d, where big D represents the diameter of the cutter, which is 75 millimeter, and small d represents the depth of cut, which is 7 millimeters. Then replacing, since both are given provided in millimeters, then the resulting approach distance will be in millimeters. Now, in order to compute the machining time, as usual for the machining time, we should add the approach distance to the distance we will move the cutter over the work part. Here, since we have that the work part is 100 millimeter wide, okay, and 3 millimeter long, you should pay attention. You should draw just a small figure to see which distance you should select. So the width is like this. This is W, this is L. When you put your cutter, it will be like this. Okay, let's say. So this is the cutter position. We have the depth here. This is D, small d, and this is big D. And now you will pass, after approaching, the approach distance will be just the distance required to put the center of my cutter at the beginning of my work part. Then I will move my cutter over the whole length in order to perform the milling operation. So I should add to the approach distance A, I should add the length of my work part, which is 300. So here I will do 300 plus the approach distance, which is 21.82. And then the machining time will be calculated as this distance over the value of the feeding rate calculated in the previous step. In general, for example, in the exams, I just ask you for the time, and you should do the previous steps. Okay. Now, for the material removal rate, in case we want to compute what is the material removal rate, we have, in this case, also, if you do the analysis on the figure, the material removal rate will be equal to the cross-sectional area times the feed rate. Okay, what is the cross-sectional area I am removing as I pass over my work part? It's equal to the depth of my cut D times the width of my work part. So this is why we did here 100. So this is W times depth of cut. And now this represents the cross-sectional area of the cut, AC. And then I should multiply it by the corresponding value of the feed rate, FR, which is in millimeter per minute. So W in millimeter, D millimeter, and FR in millimeter per minute. So my resulting unit will be in millimeter cube per minute. And for example, if I ask you to give the value in meters cube per second, so you should multiply to go from millimeter cube to meter cube. It's times 10 to the power minus 9. And to convert from millimeter per unit per minute to per second, you should divide by 60. In this way, you can convert to meter cube per second. Okay. Now, any question on this? How we got the value of the removal rate? Okay. So these were some problems on chapter 18. In case you want to do any extra practice, you have in the book several problems. Okay, but mainly these are the main ideas. Just for example, pay attention for the case of face milling, for example. Okay, so in case of face milling, you should compare always the value of W and D to know which formula to use for the approach distance. So what can change in problems of milling is that instead of giving you peripheral milling or slab milling, they can give you face-centered milling. And in case of face-centered milling, what will be different is the approach distance. To determine the approach distance, you should compare D to omega. Okay, so in case you have D larger or equal to omega, as we have seen in the previous session, you will have that the approach distance will be equal to D over 2. And in case you have D smaller than W, okay, you will have that the approach distance will be given function of W, which is the width of the workpiece, and the diameter of your cutter. Okay, so just what will mainly change between one operation and the other is the approach distance. Once we select the approach distance, we can easily find the machining time by adding the approach distance to the length over which the cutter will move over the feeding. Okay. Any question concerning these problems? Okay, so we still have 2 chapters, 19 and 20. So Monday I will upload for you the recorded part for chapter 19, and then Wednesday we can do some practice problem on chapter 19, and hopefully last week we will do chapter 20. Chapter 20 is very simple. It's a small chapter. So don't worry about the 2 remaining chapters. They are not very heavy. They are short chapters. Okay. And this
دكتور
way
سؤال
we will finish at time. Yes.
للفاينل عندنا بس 17 18 19 20
Yes.
وعندنا شيء من قبل
No.
اوكي
Okay.
دكتور كيف
Yes.
البرسنتج تبع الاكزامز؟
البرسنتج تبع الاكزامز الهايست lowest يعني عندنا الاكزام 1 اكزام 2 السميشن تبعهم 65 points. اوكي. وعندك الهايست جريد على 60%، lowest جريد على 40%، يعني بتطلع بعتقد 39 26 تقريبا. 39 highest grade، 26 lowest one، والفاينل على 35.
اوكي دكتور ثانك يو.
اوكي. هلا for the project submission, yes, the deadline is 30 April. هلا in case you need some additional couple of days, no problem. Just you tell me and you can submit when you can. Yes, you send it by email. Yes.
Doctor, I have a small question.
Yes. Yes.
Subject تبع البروجكت في مطرح حاطين 3D printing بس زايد عليها metal. فينا نحكي شوي in general بعدين يعني نقسمهم يعني
بليز بس نقوا توبيك قولوا لي، لانه صار في توبكس عدة اشخاص اخذينهم، فما يصير في repetition in topics. Just tell me when you select a topic شو نقيته.
Yes, okay. بس هي عم 3D printing ولا في كتير ناس اخذين؟
already اخذينه.
Okay.
Okay.
طب casting.
Yes, it's fine.
Okay.
دكتور انا عملت كاستنج.
انت كمان؟ طب ما ليش ما عم تبعتوا لي شو عم تعملوا؟ كيف بدي
ما
اعرف؟
كنت عارف، انا عملته وخلصت يعني.
خلص
ما كنت عارف انه لازم اقول لك عنه.
It's fine. خلص مش مشكلة، اعملي عن الكاستنج. ما اصلا حتى كل دومين
معنا
نعم. Yes.
عندنا ل April 30 ولا ل May 9؟
هلا إذا محشورين مش مشكل I extend the
آه.
deadline منا هالقصة يعني it's fine. إذا عندكم issues
أوكي.
وعدة قصص مش مشكلة إذا تأخرتوا شوي مش يعني أنا قبل كنت قايلة April 30 كرمالكم يعني طب ما واحد كتير يطول
أوكي
فيه يعني
دكتور.
رح يخلص بس it's fine يعني مش May 10 May 10 مش مشكلة. Okay.
أوكي دكتور.
Any
Thank
other
you.
questions?
Have a nice weekend.
You too. Bye bye.